Hello everyone, welcome back to my math channel again. I would like to follow up with my previous video about solving exponential equation. So in this video, I provide you more complex numbers, and we're going to learn how to use our algebraic skill and manipulate them. So let's take a look at to see what I have on the board here. So I have two questions here. The first one is simplify, and the second one is solve for x. So in the first example, the first question, you don't have to solve for x. And what we do is try to simplify the algebraic expression. And how do we going to do that? The easy way is we can turn each of the number into the same base. The power number have two components. One is the base, and on the top right corner is the power. So as long as we make them look the same base, then our task become easier to simplify them. So I'm going to simplify the top here. Now I also notice there are two numbers the same base on the top, and I have a fraction power here. This fraction power is 1 over 5, can cancel out with the power 10 outside. It's the same like 10 divided by 5 here, because this go on top, this go bottom. As long as one on top, one at the bottom, we can cancel out them. So 10 divided by 5, I will have this number become 3 to the power 2, because that will be 2, right? Time with 3 to the power minus 3. Now at this time, I'm going to leave it for now, but I'm going to turn the 9 down here, become 3 to the power 2. So therefore, when I look at this, I can cancel this with this number. Now, when they are in dot, it means they multiply together, and therefore we are allowed to cancel it. So here we left with the answer will be 3 to the minus 3. However, we don't like any answer in negative exponent like that. So we have to turn them into the positive exponent. And we're going to apply the law. It means we're going to put 1 down here, and now we can bring this number down here. And on the top, we can twist it back up. So this number will become 1 over 3. Instead of negative, now become positive. And that equivalent to 1 over 27. 3 to the power 3 is 27. So that is your answer for the first question. Now, the second question is a little bit complex, more complex. So we have to be careful when we deal with the second one. Let's check. We have the base here, base 2. We have 3x to the power 5. We have 4, so they're not the same base. But we do have this number and this number look the same. 3x to the power, 3x to the power 5x, should be the same. 3x to the power 5x and 3x to the power 5x. They look the same, so what I'm going to do is I'm going to factor out, pull out as the common factor. So on the top, I will have 3x to the power 5x, right? They look the same, so I'm pull out as a common factor. I'm going to open the bracket. Inside, I have 2x to the power 4 minus 4x to the power 3. Close the bracket. Down here, I'm going to pull out the x to the power square as a common factor. And inside, I will have 1 more x to x to the power 1 times 2 is x to the power 3 and minus 2. Now, at this point, they still look very complicated, isn't it? So I am going to have to pull out another factor from here. And notice I can pull out the factor 2, right? Because 2 times 2 is 4. And also x to the power 3. So outside, I have 3x to the power 5x time with, I'm going to pull out the 2 as a common factor for both number. And the x to the power 3, the least power is x to the power 3. I'm going to open another bracket. And in here, I left with 1x minus 2, because 2 times 2 is 4, right? And x to the power 3, I already pulled it out, so it's just like that. And down here, I have x squared and time with x minus 2. So at this point, I look at my top part and the denominator. I see they all multiply together, right? They're in bracket. So it means this term multiplied with this term multiplied with this whole bracket. So again, they look the same for x minus 2, x minus 2. So I'm going to cancel this and this. So I left with x squared down here. One more term I can cancel. This is x to the power 3 and this is x squared. So I'm going to get rid of that. And on the top, it left with power 1 on top here. So at this point, there are no thing I can simplify further because this is power 5x and this is x to the power 1. So let me see. So I can combine this x, right? This is x to the power 1. This is x to 5x. So I can combine this with this number. And I left with the number 3 and number 2. I can join become 3 times 2 is 6. And the x here, I can join them, which is 5x plus 1. So that is the final simplification I can do for this algebra. Okay. So I hope you follow it. It's a little bit complicated, but if you practice, it will not bad. Okay, so now I'm going to go to the next question. I want to show you how to solve for x here. So here is the equation, and we're going to solve for x. So here we just simplify, and this is our final simplification. And now we're going to do something with this. What I noticed is this is 4 and this is 2. It means I can turn them into the same base. So I'm going to change this equal 2 to the power 2. And on the top, I still have the square root of x plus 1 equal 2 to 3x minus 2. So at this point, I have the same base, left side equal right side. It means I can pair the top equal the top, no problem, because they have to be equal to make this equal, right? So I'm going to ignore the base 2. We'll say 2 square root x plus 1 will be equal 3x minus 2. I don't have room to continue, so what I'm going to do, I'm going to have to erase question here. To continue with this. So I'm going to put them separate like that, so it's easier for you to follow. Now I'm going to copy this expression to this bar. So now I have this question is 2 square root of x plus 1 equal 3x minus 2. Now you realize that this is the solving radical equation, right? And what do we do in the procedure of solving radical equation? We have to restrict the number inside the radical, right? So I'm going to say x plus 1 have to be bigger or equal 0. And we're going to move the 1 over. So x have to be bigger, equal, minus 1. So this is the restriction, right? Restriction. Make sure after we solve, the x have to be bigger than or equal minus 1 at least. So let's solve and see what's going on here, right? So to solve this equation, what I'm going to do is square both sides, right? Say square both sides so that I can get rid of the radical. So that will become 2 square root of x plus 1 equal 3x minus 2. And make sure I have to square the whole expression, right? Both sides like that. So this number will become 4, 2 to the power 2 is 4. And this will cancel out, the power here will cancel out with the root. And we left with only x plus 1. This one, we have to use the formula, right? Because this is the same like a minus b to the power 2. So the formula say will be equal a square, which is this number square. So it will become 9 x square, a square, minus 2 times a times b. 2 times a times b is 2 times 2 is 4. 4 times 3 is 12. 12x. And this number will become b square, which is 2 square, which is 4. Now I'm going to distribute together. So I have 4x plus 4 equal the whole thing here. So what I'm going to do is I'm going to toss everything to this side, right? Adding with this number. So let me copy this first. 9x squared minus 12x plus 4. And make this left side become 0. And I'm going to move everything over. So 9x squared still 9x squared. 4x will move over here. Positive will become negative, right? Negative 4x. Negative 4x add to negative 12x will be negative 16x. And the 4 here is positive, move here become negative. So negative 4 with positive 4 will cancel out this number. And we get 0, right? So we're not worried about that term. At this point, I can factor out again with the x. And in here, I have 9 x. If I factor out this, I have 9x minus 16. So to solve this, I will set one bracket equal 0. So x1 will be equal 0. That's 1x. And another x will be 9x equal, if I set this equal 0, I move this over, so 9x will be equal positive 16, and x will be equal 16 divided by 9. Divide both sides. No, I cannot do anything. So that is the answer. I'm going to simplify this by put them become a mixed number, right? So I have 1 here and 9 down here, and 5 on top, 7 on top. So 1 and 7 over 9 is one of the x value. So what is a condition? We look back the condition. What do we say here? We say x have to be bigger than equal minus 1. Bigger equal minus 1. So if x is equal 0, is that acceptable? Yes, it satisfies condition, right? So yes. because 0 bigger than minus 1. Now this 1 is positive number and bigger than 1, so that also satisfies. So both answers seem to be yes. But remember, for solving the radical equation, we have to make sure that left side and right side, if we put them back, right? So we have to perform the check. So to complete this question, you have to perform the checking as well, because this is the radical equation. So I'm going to erase some of this here and continue with checking, right? So I'm going to say check if left side equals right side. Now the first one, I will check x equals 0. So if x equals 0, I have 2 times with, this is 0 at 1, so it's just 1, right? And this is just like 2 times with 1, it's just 2. And here I have 3, x is 0, substitute 3x by 0, minus 2. So we are in trouble because 2 not going to be equal minus 2, right? Because this will become 0 and we have with minus 2. And here we have 2. Now how the 2 equal minus 2? So we'll say recheck. So this number, we thought that okay when we check the condition, but it turned out if we check into the equation, it doesn't work out. So we say not okay. Not okay or recheck it. So that is the first check. Now I'm going to check with this number. Now to check this number, I'm going to say, I'm going to leave this in this form. X equals 16 over 9 to make it easy. Instead of using the mixed number, I'm using this number to check. So I'm going to substitute into the left. So let's put in here. This is the left side we're supposed to check. And this is the right side we're supposed to check, right? This number. So I am going to use the x equals 16 over 9. So we have 2 times with this will become 16 over 9 at 1. And that will be equal to 2 times with, we'll do common denominator, right, on top, times 9, bottom times 9. 16 at 9 is 25 over 9, and that in square root. So let's take it out. So we have 2. Square root of 25 is 5. Square root of 9 is 3. So this number will be equal to 10 over 3. Now let's check this. You see 3 times 16 over 9. For x, I'm going to substitute that, right? Minus 2. So I'm going to cancel 3 with the 9 here. I got 16 over 3 minus 2. We'll do common denominator times 3. So that will be equal to 10 over 3. So the second root is work. They both left side equal 10 over 3 and right side equal 10 over 3. So we will say, yes, this answer is correct. So the x will be equal to 16 over 9. That is the x value after we solve the radical equation. So you can see that for the radical equation, we not only to check back with the condition we first stated, we also have to check after we get the x value. Make sure you check again to see are they both okay or just one of them okay. And in this case, just one root is valid and the other root x equals 0, even though they satisfy this condition, but it not satisfied when we check left side different from right side. So that's the way how you handle the radical equation. So solving radical equation is a little bit complex when you have to check it back, but make sure you check it, right? And that's how it looks like. Okay, so we're done. I'm going to finish these two questions here for you. So let me see. Now this equation, they have the same base, but we have to be careful because they not multiply, right? They're adding. So in terms of adding like this, you cannot do anything except that you have to, again, factor out, right? So they have the same base, so I'm going to factor out the 4 to the power x is the common factor. Inside, I left with 1, so that I can get back to this. And the next will be, this is 4, x plus 1, and we have x. It means we have to add another 4. So when you multiply, you add the power 4, x plus 1. So we get back to that. So that's the situation, right? Equal 40. So at this point, you have 4 to the power x times with 5 equal 40. So now you can divide both sides by 5 and get rid of this. So we have 4 to the power x equal 40 divided by 5 equal 8. So it means that 4, so I'm going to turn them into the same base, right? So I will have 2. I change this into base 2 to power 2x, right? Equal 2 to power 3. So 2x will be equal 3, and x will be equal 3 divided by 2. And that is our answer for this question 2. Okay, now this is not a radical equation, so I'm not going to bother to check it, right? That is x equal 3 over 2. The last question, how we're going to deal with the last question. And I don't think I have enough room, so I might have to erase this ball again to continue with that last question. So the last question looked very complicated, right? That's why I chose a complicated question to show you, so that when you do the simple question, it's easier for you, right? Okay. So now, when I look at this pattern, my institution is, how do I'm going to make it similar? And it looked like we have 3 terms, first term, second term, 3 terms. So something like that, you should inspect that maybe I can turn it into the quadratic function, because the quadratic function have 3 terms, right? So I want to say let A equal, now I see this 5 to the power 2x, I see 5 to power x. So I'm going to say let A equal 5 to the power x. So I'm going to make like that. So it means I can rewrite them as 2. This will become A to the power square, right? Because the 2 here. And 5x I substitute by A. So I change this become A to power square. Minus 52A, because 5 to power x equal A. So I substitute this bracket by A plus 50. So at this point, I'm just treat them like a quadratic equation. I'm going to solve for it. So, yeah, equals 0. So I'm going to divide both sides by 2, right? I'm going to divide both sides by 2, and I'm allowed to do that. So I left with A square minus 26A plus 25 equals 0. 0 divided by 2, which is 0. So at this point, I treat this as a quadratic function. I have 25 times with 1 to split it. So I will split them, become 2 brackets I factor out. So the first number will go in here, and I make sure when I add these 2 numbers, I assign the correct sign for each of them. Minus 25 and minus 1 equal minus 26. So that's okay. So this number will go in here like this. And this number will go in here like this. So I check the last term, 25 times with minus 25 to minus 1 equal plus 25. So I'm okay. So now I'm going to solve for A. So the first bracket will be equal 0, move it over. A equal 25. That's the first answer. The second answer, A equal 1. Second answer. Now let's look back again. I have A equal 5 to power x. So I'm going to substitute this A by 5 to power x equal 1. So what does that tell us? Now I am not going to be able to change the 5 become a 1 unless the x here have to be equal 0. Because if I have 5 to power 0, then yes, it's equal 1. So x equals 0 is the first answer. The second answer is A equal 25. I'm substitute this with 5 to power x again, equal 25. So I'm going to change this become 5 to power 2x equal 5 to power 2, right? 25 5 over 2. So 2x will be equal 2 because the base is the same. I can pair this one with this one equal. So x will be equal 1. So that is the two answer I got. X equals 0 and x equals 1. Again, this is not the radical equation, so I'm not going to bother to check it. And I'm going to end my video lecture here so that, so sorry. Yeah, sorry. Okay, so this is how you deal with the solving solving x for the exponential equation. And these skills are related to each other, right? It built up from the past to be able to do all of this in the efficient way. So as long as you practice, but you get some idea how we're going to deal with some algebraic expression look like a little bit complicated. But if you learn from Math 10 and you keep up with it, then you know what I mean and you will follow along with it. And you are online, so if you don't understand, you can rewind the video and watch it again and again. I hope that I won't go too fast for my teaching. Usually I'm not a fast teacher. I didn't go too fast. I remember my Chinese teacher before. He went so fast. He make us crazy. But I'm not tired fast like that. So anyway, I hope you can follow me along. Thank you for watching and have a good day, everybody. Bye for now.